everyone. In this session, we are going to deal about block diagram reduction technique in control systems. So, what is normally a block? A block consists of a single block or combination of blocks. They used to represent the control system in a block pictorial form. Okay, so it's a block in a block. We'll have control transfer function in a block will be present here, and here we'll have a summing point. Here we have a summing point, and this one we'll call it as a takeoff point. Okay. So, so we have some rules for reducting the block diagram. So, for example, if you need to find the transfer function of a block diagram, you have to reduce the blocks and the final output, because in the blocks there will be a transfer function or gain, right? So, if we reduce that, we'll have a transfer function, obviously. Okay. So, here the rule one is, first you have to check the blocks connected in series or in, and you can simplify it. And next one, you have to connect in parallel and you have to simplify. So how we can simplify it, we'll see in upcoming sessions. So next rule is, so you have to check whether the blocks are connected in feedback loop and simplify it. And next we have to change the takeoff points, whether it can be shifted to the before the block or you have to shift it after the block in order to simplify the system. And next one is, if next rule is, if we have difficulty with the summing point, we can shift the summing point also. So you have to repeat the above steps and you have to make it as a single block. So that is how we have to reduce the block diagram. So we'll start with the problem. So consider the block diagram shown and you can simplify it. So this is your block diagram. So first, how we can simplify it. So you have to check whether first you have whether any two blocks in series or in parallel. So here see, you have these two blocks in series and here these two blocks in parallel. Okay. So if you have the blocks are cascaded or in series, you can just multiply the gains or transfer function directly. So when you're multiplying these, you'll get it as G1 into G2. And when the blocks are in parallel, you have to just add it up. When you're adding, you'll get it as G1 plus G3. So this will be your output. So when you're multiplying it, you'll get G1 into G2. When you're summing it up, yeah, you'll get G1 plus G2. So what is the next process? You have to convert this, right, this block into a single block. How we can make it is, see here you have a feedback loop. So how we can reduce the feedback here is, so G, or you can take this as G and this as feedback. So G divided by 1 plus feedback. Feedback here is H1. So here your G is G1 into G2 and here your feedback is H. So you're getting the answer as, sorry, into GH. So you're getting the answer as G1 into G2 divided by 1 plus, what is your G? G1 into G2 and H is H. So that's all with the step. According to the next step is, you have to take this, we are going to shift this point before here. So in order to simplify. So when you're reducing it, your block will be like this, divided by G5. Why we are dividing it G5? This is the rule. When you are taking the point, right, takeoff point, before you have to add here, this one in the denominator. Okay, make this note here. And your next ones, apply the same rule as it is. So these two are in series. So sorry, these two are in feedback loop. Reduce the feedback loop. Reduce it by simplifying this feedback. So how we can reduce G by 1 plus G into H. Here your G is this and your H is feedback. Listen, always your H is feedback. Okay. And G is the total function which we are simplifying it. Okay. So when you're simplifying it, you'll get this block will be simplified. And here this block simplified block and this will be in series, so you can just multiply and the particular block and this feedback you can simplify. So you have this, we have simplified this one and these two are in simplified it by feedback loop, and at last you'll get this. So this will be your transfer function. Okay. So that's all with the block diagram reduction. Thank you.